Welcome to Lesson 1. We are going to use the D equals RT formula to understand driving data. Our objectives are to use the formula distance equals rate times time. Oftentimes when we drive, we ask ourselves how long is it going to take to get somewhere, or we need to drive in order to get somewhere in a certain time, or how far is it going to be if for this long over a given rate. Notice that D stands for distance, R stands for rate, and T stands for time. We can rewrite this equation in three different ways. We can leave it like this to solve for D, or we can solve for T by dividing both sides by R. So then we get that the time is equal to the distance traveled divided by our rate, or we can solve for R by dividing by T. And in that case, we have rate will be equal to our distance traveled divided by our time. Let's look at some sample problems. In this first example, this is a base example, a car travels at an average rate of speed of 50 miles per hour for 6 hours. So how far does this car end up traveling? Well, again, this is our basic distance equals rate times time formula. When it asks for how far, we know we're asking for distance. So we would want to use the formula written as it originally is, distance equals rate times time. So to find the distance, we take our rate, which is 50 miles per hour. This is our rate, and we multiply it by our time, which is 6 hours. This gives us a total distance of 300 miles. And I know it's miles because we were using miles when we were looking at our rate. This is miles per hour. So we've gone total distance of 300 miles. Let's look at a second example. In this example, Jack lives in New York and will be attending college in Atlanta, Georgia. The driving distance between the two cities is 883 miles. So we know that's a D right there. Jack knows that the speed limit varies on the roads he will travel from 50 to 65 miles per hour. He figures that he will average about 60 miles per hour, that's his rate, on his trip. At this average rate, for how long? So we're trying to figure out our time. We don't know our time. How long will he be driving? Express your answer rounded to an hour and to the nearest minute. This is going to require us to do a little bit of conversion. But let's go ahead and figure out our time first. So remember that we can use our formula rewritten for time as distance divided by rate. So time is going to be distance divided by our rate. Well, our distance we said was 883 miles, and our average rate that he expects to drive is 60 miles per hour. If we put this in the calculator, we get a time of 14.71667 hours. Well, this doesn't tell us how many minutes. We know it's 14 hours and then a 0.716667 of an hour. So how do we figure out how many minutes that is? Well, if that's 0.7 of an hour, all we need to do is multiply that by 60. There's 60 minutes in an hour. So if we multiply by 60, we can determine, let's actually multiply 0.716667 times 60, and we'll get 43 minutes. And that makes sense because 0.5 would be 30 minutes. This is 0.7, so it's close to between a full 60 and 30 minutes, somewhere in between there. So that makes sense. So it took him 14 hours, or it will take him 14 hours and 43 minutes in order to travel from New York to Atlanta. Let's look at our next example. In this example, Kate left Albany, New York, and traveled to Montreal, Quebec. The distance from Albany to the Canadian border is approximately 176 miles. So that's a distance. The distance from the Canadian border to Montreal, Quebec is approximately 65 kilometers. Notice we have different units of measurement. That's because here in the United States we use the standard measurement system, but then in other countries they use the metric system. So we need to have the same measurement. Either we need to convert both to miles or we need to convert both to kilometers. The entire trip took about 3 hours, so that's our time. We want to know the average speed for the trip. So we need to know rate. Let's first go ahead and write the equation that we are going to be using. Remember, go ahead and look back, have these in your notes. Rate is just the distance over time. Notice that these are very similar. They're both distance as the numerator, and then it's either rate or time as the denominator. So I'll put distance over time. Well, we have two different distances that we need to add together. We need to use this formula here to help us convert. And let's go ahead and convert from kilometers to miles, since that's typically what we use. Well, we know that 1 kilometer is the same as 0.6 miles, and 1 mile is the same as 1.6 kilometers. Since we are going to change from kilometers to miles, let's go ahead and use the top conversion. We know our kilometers. Our kilometers are 65, and we want to know how many miles that is. So we can multiply it by the conversion percent here, or the conversion amount of 0.621371. So let's multiply that. And we get 40.4 miles approximately. And then we need to add that to the 176 miles that she's going to go in order to get to the border. Combining those together, we will get 216.4 miles. So now we have figured out our distance. Now we can use our equation, rate equals distance times time, in order to solve. So our rate is equal to 216.4 divided by our time. The entire trip took her 3 hours. So now we can figure out our rate. And that's 72.12 miles per hour approximately. Okay, let's try another example. In this example, Barbara uses her car for business. She must keep accurate records so that she'll be reimbursed for her car expenses. When she started her trip, the odometer read 23,787.8 miles. When she ended the trip, it read 24,108.6. Barbara's car gets 32 miles per gallon. Her tank was full at the beginning of the trip. When she filled the tank, it cost her $40.10. What price did she pay per gallon of gas on this fill-up? So this is a little bit of a different problem, but let's use our problem-solving skills to help us solve this. All right, what do we need to know first? Well, we need to know how far she drove. Well, we know what her beginning and her ending odometers read, so we want to subtract those. When I subtract them, I find that she went 320.8 miles. So that's her distance, 320.8 miles. Okay, now it says Barbara's car gets 32 miles per gallon. So we want to determine how many gallons did she use for this trip. Well, if we go 320 miles, we can divide that by 32 miles per gallon to determine how many gallons she must have used. And we can see that she used 10.025 gallons. Okay, we're almost done. It cost her $40.10. So what price did she pay per gallon of gas on this fill-up? Well, she purchased or she had to have purchased 10.025 gallons in order to drive that distance. If we take the 40.10, which is what it cost her to fill up, and we divide it by the 10.025, we should be able to figure out how much she paid per gallon. So let's go ahead and do that. 40.10 divided by 10.025. We find that she paid $4 per gallon. All right, let's try one final example. In this example, your friend left to go skiing at 8 a.m., traveling 55 miles per hour. The distance to the resort was 135 miles. You left 1 hour later at 9 a.m., traveling 65 miles per hour. Will you beat your friend to the resort? How far apart will you arrive? Go ahead and pause the tape and see if you can figure this problem out. And then come back and let's work it together. Okay, so what we need to know first is how long did it take your friend to go 135 miles? So we're wanting to know time. And remember, if you go back to these equations, if you have them in your notes, it's very easy that time is just distance traveled divided by the rate. Okay, we know the distance is 135 miles to the resort, and the rate that your friend went was 55 miles per hour. So let's see how long it took him. It took him 2.454545 hours. Now again, we can't do much with the 0.4545. That just repeats. But how much of an hour is that? It's probably close to 30. So let's actually figure that out. Let's take 0.4545 and multiply that times 60 minutes in an hour, to determine what fraction of an hour that is. And that is 27 minutes approximately. So your friend got to the resort in 2 hours and 27 minutes. Now let's see how long it takes you to get to the resort. So again, we'll look at the distance, which is 135 miles, but your rate was 65 miles per hour. If we take 135 and divide it by 65 miles per hour, we find that it takes you 2.07 hours to get to the resort. So what fraction is the 0.0769 going to be? That looks like about 4.6 minutes, or we'll just round to 5 minutes. So it took you 2 hours and 5 minutes to get to the resort. Well, you left 1 hour later. So, did you beat your friend to the resort? Hopefully your answer is no, just by looking at it. But let's look at your total time. Well, your total time was 2 hours and 5 minutes plus the 1 hour delay. So you had a delay. That means, all things being equal, it would have taken you 3 hours and 5 minutes to get to the resort. If you subtract 2 hours and 27 minutes from 3 hours and 5 minutes, what is that difference? Well, that can be difficult to subtract because we have hours and minutes. Sometimes it would be easier just to put it all in minutes. Well, 2 hours is 120 minutes plus the 27 minutes means that it took your friend 147 minutes total. And you took 3 hours, which is 180 minutes, plus 5 is 185 minutes. So let's subtract that. And that means it took you an extra 38 minutes to get there after your friend arrived. So what happened? Your friend arrived, and 38 minutes, you arrived. And that's how you solve these types of problems. Okay, that concludes our lesson 1 today for using the distance equals rate times time formula to understand driving data.